Hey everybody, this lesson is to get you ready for your upcoming test. We are currently on quarantine with the coronavirus. Anyway, so I do have another lesson that looks very similar to this. If you go to the IM3, the Integrated Math 3 lesson at Mr. Math Blog, there's one very similar. It's very similar to this, just a little bit different techniques on doing this. So here it says find the area of this triangle to the nearest tenth. Okay, all right. So I'm getting my kids to read the directions. The nearest tenth is one decimal. Remember, it goes decimal and it goes tenths, hundreds, thousands, 10,000s, 100,000s. Remember that? Okay, anyway, so if they give you two sides and the included angle, then the formula is 1/2 the product of these two sides times the sine of the included angle. So as long as I'm doing my math right, I get that. And I was doing this on my calculator, and you can check my answers. I might have made a mistake, but the work is correct. I just don't know if I had the right, if I was in degrees or radians or gradians in my calculator, so I had to check several times. All right, so find angle C. Okay, so angle C, we're going to use the law of sines on this guy right here. The law of sines is the sine of this angle over the side that's opposite equals the sine of this angle over the side that's opposite equals the sine of this angle over the side that's opposite. Okay, that's what this says right here. Okay, now since I don't know angle C or the opposite side, I need to find angle A first because I know its opposite side. So I'm going to use that ratio. Once I find angle A, then the triangle is 180, and then I'll do the rest of that. Okay, so let's do that first. Okay, so the sine of A over 4 equals the sine of 100 over 9. And again, hopefully my calculator is working correctly. I don't have a scientific calculator with me at home. They're in my classroom, and I'm quarantined from going to my classroom, so I can't even get them. So anyways, the work is correct. I just don't know if my calculator is in the correct mode on my cell phone. So this is what my calculator on my cell phone says right here. So here I'm going to go ahead and okay, so what I did is divided both sides by 9, and then I'm going to get this decimal right here, and hopefully my calculator is correct with the sine of 100 equaling this decimal right here. So I'm going to do this times 4 divided by 9, and I get this value right here. Okay, and then that means that the angle A is the inverse sine. So I hit shift sign in my calculator of that decimal right there, and that's going to tell me what angle A is. So angle A is about 26 degrees, okay? So then angle C, remember 180 in a triangle, angle C is going to be the rest of 180. So I take off the 100, I take off the 26. Now remember, it says round to the nearest tenth. So to the nearest tenth, this is 54, but to the nearest tenth is 54.0. Okay, so just make sure you're following those directions right there. Okay, so find the measure of angle C to the nearest tenth here. Okay, so here we have to use the law of cosines because there is no angle right there. So the law of cosines is we take any side squared, it equals the sum of the other two sides squared minus 2 times the sum of their times the product of the other two sides times the cosine of the opposite of that angle. Notice little b is opposite big B, little c is opposite big C, little a is opposite big A. And since we're looking for C, then we're going to use this side squared equals this side squared plus this side squared minus 2 times this times the cosine of whatever that is. So that's what we're going to do here. Okay, so let's go ahead and square those. I get that. And then 100 plus 81 is 181. Then we'll subtract 181 from both sides and we get that. And then we divide both sides by negative 180, and here we are. So then we do shift cosine. So shift cosine of that angle gets me about 49.5. Okay, it says round to the nearest tenth, so 49.5. Okay, find the area. Okay, this is the same triangle that we just dealt with, so we already know that the angle is 49.5. So the area, we're going to use the law of sines again, not the law of sines. Half the product of the two sides times the sine of the included angle. Okay, so as long as my calculator is doing things correctly, we should get about that right there. It doesn't say where to round. When it doesn't say where to round, I always go out about 3 decimals right there. So to the nearest thousands, tenths, hundredths, thousands right there. Okay, so I get about that in my calculator. All right, and then tell me if I'm not getting the correct answers. I make mistakes all the time. I'm human. Okay, even Miriam's human. She makes mistakes too sometimes. Greatest kid, you know, anyway. All right, so convert degrees to radian measure. So here we're going to multiply by pi divided by 180. So here we go. And then with the 70 and 180, the zeros cancel, and we get 7 pi over 18. Okay, here on the second one, I'm going to divide both sides. I know 5 goes into both these guys, so I'll divide these guys by 5 first, and when I divide by 5, I get that. And then I know 3 goes into both these, but 9 goes into both these. 9 goes into 18 and 9, 21 times, and this 4 times. So when I divide by 9, I get negative 21 pi over 4, okay? All right, so here we're going to convert from radians to degrees. So we're just going to multiply by 180 over pi. Okay, so when we do that, we get that, and then just start canceling out. And those are our answers right there, as long as I did things correctly. And again, sometimes I don't. Okay, so right here, quadrant 4. Okay, quadrant 4. Okay, so cosine's positive in quadrant 4. So it says find the sine and cosine of those guys. Okay, so here we go. Remember, tangent is equal to sine over cosine. If we multiply both sides by cosine, we get cosine times tangent equals sine. Okay, so we'll go ahead and multiply. We'll substitute this tangent value in right here, and then we get negative 4.580 times cosine equals this sine right here. Okay, all right, and then now we're going to substitute that in for sine squared plus cosine squared equals 1. Okay, remember sine squared plus cosine squared equals 1. And the reason why this is in red is I substituted this in for this right here. Okay, so let's square negative 4.580. Okay, that should be a decimal right there. Anyway, so when we square that, we get that, okay, and then we're going to combine like terms, okay. The like terms, they're both cosine squareds now, so 20.9784 plus, or 64, sorry, plus 1 is 21.9764 cosine squared. Now we'll divide both sides by this red guy right here. So when we do that, we get that decimal right there, and then square root, don't forget it's plus or minus, and then we got to remember quadrant 4 where cosine is positive, so we don't have to worry about the plus or minus, it's only the positive. Okay, so when we do that, we get cosine to be about that. Now it does say round to the nearest hundredth, but I'm going to keep this in my calculator because this is still in my calculator, and this goes right here. So when I plug that in right there, because it does say find the sine also, so the sine is going to be that. So there's our sine and cosine right there. Okay, remember quadrant 4, only cosine's positive. All students take calculus. Okay, so without using a calculator, evaluate the trig functions. Okay, so tangent of 480. Remember 480 is a full circle plus 120. So we can take out that full circle right there, 360, because they start repeating themselves. And so we have the tangent of 120. So if we graph that, it would be right there. So remember, cosine of the angles goes 3, 2, 1. So this would be the 1 part right here. This would be 3, and this would be 2, and this is 1 right here. Sine is 1, 2, 3. Okay, so this would be, and these are roots. So root 3 over 2, root 2 over 2, root 1 over 2, which is 1 over 2. This is 1 over 2, root 2 over 2, root 3 over 2. Tangent, I just showed you guys that tangent goes 1/3, which is 1 over root 3. So you'd have to multiply by root 3 over 3, or 1 or root 3. So this is the root 3 right there. All students take calculus, so sine is positive, everything else is negative, so tangent's going to be this value right here, negative root 3. Okay, so that's the answer right there. Okay, so man, I keep getting these little things, and then when I restart it says I've got it anyway. Alright, so cosine of negative pi over 2 is down over here, okay? Pi over 2 would be up here. Clockwise is pi over 2, but negative pi over 2 is down here. This has the ordered pair right there of 0, negative 1. Remember, it's cosine, it's comma sine. Cosine is before the, C is before S in the alphabet, so cosine comes first, so cosine of that is 0. All right, okay, so this guy right here, full circle, is negative 2 pi. Okay, it's also 2 pi. Here's 2 pi going in this direction, but negative 2 pi is a full circle. So it just starts repeating itself. We're going to start taking out the full circle. So negative 2 pi in terms of this denominator right here, 3, is the same as negative 6 pi over 3. So let's take out the negative 6 pi's over 3's, okay? So negative 16 pi over 3 is negative 6 pi plus negative 6 pi over 3, and that's negative 12 pi over 3, plus an additional negative 4 pi over 3. Full circle, they're gone because they just start repeating themselves. So we're looking at the sine of negative 4 pi over 3. Well, here's positive 4 pi over 3. Remember, it goes, this is pi, this is 1 less, this is 1 more. So this would be 4 pi over 3 right here. Remember that they go 6, 4, 3. Over here, the denominators go 6, 4, 3, and then 6, 4, 3. Here's my 3 right here, 6, 4, 3. This is pi over 6, pi over 4, pi over 3. This is 1 less, 1 more, 1 less than twice right there. Okay, so this is positive 6 pi or 4 pi over 3, but negative means we got to go that same amount in that direction, and that'll be over there, where the sign is positive. Okay, the sign is positive, everything else is negative. Okay, let's go back over here. Sine goes 1, 2, 3, so it's going to be root 3 over 2. Okay, it's positive, root 3 over 2. All right. Okay, so here we're going to graph these guys. Now, I haven't been with you guys because of our shutdown. I did graph this one with you guys in class, but our coronavirus shut us down, and we're going to be shut down for I don't know how long anyways. I told you guys how to graph cosine, and the cosine, there's one full period and 2 pi. So cosine starts and ends at 1, halfway at negative 1, halfway at 0. But since we got this 4, our amplitude is 4, we're going to change this to 4 and this to negative 4, and then everything multiplies by 4. This is still 0. So this one's going to be starts and ends at 4, halfway at negative 4, halfway at 0. So what I'm going to do, start it here, end it at 2 pi over here, halfway at pi at negative 4, and then halfway at 0. Okay, let's do that. Okay, so here it is, and let's do the other side since the graph is there. So we're going to start over here, starts and ends at 4, halfway at negative 4, halfway at 0. Okay, so there's that right there. All right, and there's our groovy graph. Okay, sorry I'm not in class. I can't make a nice smooth curve, but that looks pretty good. All right, how about this guy right here? Okay, the sine wave, it starts and ends at, okay, one period is in a full 2 pi, so it starts and ends at 0, half at 0. Okay, so we're going to start at 0 and end at 2 pi at 0, halfway at 1 pi at 0, half at 1, half at negative 1. So the sine curve would start here and here, halfway here, halfway here, halfway here. Okay, but this negative 1/2 says multiply that by negative 1/2, so this is going to be negative 1/2, and this is going to be a positive 1/2. So when we do that, there it is right there. So we're gonna start it and end it at 0. So start here, end here. We're gonna go halfway at negative 1/2, so right about here. I'm sorry. Start here, end here, halfway at 0, halfway at negative 1/2, halfway at positive 1/2, because we're just multiplying this by negative 1/2 and this by negative 1/2. We'll do it on that side also. Okay, so when we do that, we get those, and there's our graph right there. Okay, isn't that a beauty? All right. All right, I wasn't here to teach you this, so but it's the same thing, and there's several correct answers on this. So I'll be able to interpret the correct answers, but the most common answer is this, you guys. Look, it starts and ends at zero, halfway at zero. That's a sine wave right there. To me, unless you do a cosine with a phase shift, which is in the next lessons. Okay, so sine wave starts and ends at zero, half at 1, half at -1. And since the max right here is at 2 and the min is at -2, then the amp in front of the number of sine is 2. Okay, so let's at least get that part right there. And the period right here, the period is, it's not 2 pi, it's in 2. So since the sine wave and cosine wave, the period is in 2 pi, we take 2 pi and we divide that period by 2. So 2 pi divided by 2 gets us just pi. So that's the number that goes in front of our angle. Okay, so I didn't get to teach you guys that this year because of our coronavirus issue. So anyway, so we take 2 pi, which is regular sine wave, and whatever that period is, we take 2 pi and divide it by the period that they give us, and so 2 pi divided by 2 is pi. That's why this little rascal is pi. Now, like I said, there's other correct answers. We can do a cosine wave on this or sine wave, just depending on the phase shifts that you do. So that's one of the correct answers. That's probably the most common one right there. All right, so here, this guy is, it says identify everything. Okay, so this 3 says that there's 3 periods in 2 pi. This says phase shift to the right pi over 3, and this says phase shift down 1.5 right there. So here's 1.5. So I'm going to do a dotted line right there. I'm going to do a dotted line at pi over 3 right there. Okay, and then this 1/2 is like starts and ends at 0, halfway at 0, halfway at 1, halfway at -1, except it's going to be 1/2 on that. Okay, all right. So there we go. So the shift of the origin to the right pi over 3 and down 1.5. So now the new origin is right there. Okay, so we can disregard. We've taken care of that. We've compensated that and that with this new origin. So now this is our new pretend origin right there. Okay. Now this 3 says that there's 3 periods in 2 pi because sine is just 2 pi. Okay, so then if it's like dividing both sides by 3, so there's going to be 1 period in 2 pi over 3. Okay, so my 1 period is going to start here and end here because there's my 2 pi over 3. So it starts and ends at 0, halfway at 0, halfway at 1, but it's going to be 0.5, so we're going to go up 0.5, so it's at -1.5, halfway at -1. Okay, so let's go ahead and do that. Okay, so there it is right there, and typically I want you to graph at least one cycle or 2 pi, but given the graph right here, there's our graph right there. Okay, all right, so let's look at this rascally rabbit. Okay, so remember now tangent, every tangent period is in 1 pi. Okay, so here's our I was supposed to talk to you guys about, but I couldn't. But anyway, so the tangent, it's on a scale of 2 pi. It starts and ends at 0. Halfway has asymptotes, and then it goes +1, -1, +1, -1. Okay, so from here to here. Okay, now there's 1 period in just pi. So this cycle, can you see this cycle repeats every pi? Okay, so this cycle repeats every pi. This little down part, if I kept going, it would go right up here. There'd be an asymptote right over here. Okay, so for every 2 pi, my gimmick is it starts and ends at 0, halfway at 0, halfway has asymptotes, and then it goes +1, -1, +1, -1, and then it just goes. Don't forget sound effects. Okay. All right, and so the range is it goes up and down, and your domain is it's everything except the asymptotes, and so the domain is all numbers except every pi over 2. That's where the asymptotes come up. So anyway, so here we go. So this guy's going to be we're going to shift the origin to the left pi and up 3. So to the left pi and up 3. So once we got that covered, okay, now from the origin we're going to graph everything except this stuff because we compensated it with this right here. Okay, now this 1/2 says there's 1/2 of a period, 1/2 of a period in pi because pi, sorry, tangent happens every pi. So the period is in every pi for tangent. So here is 1 pi right here. This is negative pi over 2 to positive pi over 2. So this is pi. So the cycle just goes every pi. And then, so this 3 right here says that, what 3? No, this 1/2 right here says there's 1/2 of a period in every pi because the tangent is every pi. Okay, so there's going to be 1 period. It's like multiplying both sides by 2. So if there's half of a period in every pi, then there's 1 period in every 2 pi. Okay, so here's negative pi, here's positive pi. So I'm going to put another asymptote right over here. Okay, every pi, there's an asymptote. Sorry, I did it every 2 pi. So there's an asymptote. I should have put one right here. I guess I didn't right here. Okay, and then so the tangent between the pi's for every pi's, it starts and it just keeps going. So the 2 tells us to go up and down 2. This 2 right here says to go up and down 2 instead of up and down 1. Okay, so we're going through, it's going to go through right here and right there. So let's see what our groovy tangent does right there. So it starts in, shoot. So it's going right up through there. Sorry, that wasn't a good last minute description. Anyways, if that isn't clear, then go look at my review I did before. Okay, guys. All right. I hope you guys do well on your test that comes up, and maybe we'll do a virtual test. Take care.